So in this problem, we're going to divide that cubic in the numerator by this linear polynomial in the denominator, binomial. So, okay, I've set up the long division to start working on it. Notice I needed a placeholder for x. There's no x term in the numerator, so we had to give it a 0x term. That placeholder is very important. So now we're set up to start. So we start by asking how many times does x divide into 5x cubed? It goes in 5x squared times. As you can tell, it's 5x squared times x is 5x cubed. That shows it was the right thing. 5x squared times negative 2 is negative 10x squared. So then we subtract. 5x cubed minus 5x cubed leaves no x cubes. Negative 2x squared, negative a negative makes a positive 10x squared. So 10x squared minus 2x squared is 8x squared. Then we bring down the next term, even though it's just 0x, and do this again, asking how many times does x divide into 8x squared? X goes into 8x squared 8x times, because 8x times x is 8x squared, and 8x times negative 2 is negative 16x. Now we subtract again. That's supposed to be a subtract out there. So we end up with 8x squared minus 8x squared leaves no x squareds, and 0 minus a minus makes a plus 16x. We bring down the last term, that plus 1, and one more time ask, how many times does x divide into this term, 16x? It goes in 16 times, because 16 times x is 16x. 16 times negative 2 is negative 32. Then we subtract one last time for this problem. 16x minus 16x leaves 0x. 1 minus a negative 32 is 1 plus 32, leaves a remainder of 33. So this long division process reveals to us that the quotient is 5x squared plus 8x plus 16 with a remainder of 33. So plus 33 divided by the original divisor x minus 2. So here we have our solution to this long division problem.